Hi there, it's Mr. Thill again. I'm here with my lab assistant Ellen, and today we're going to do another little science experiment that kind of talks or addresses chemical properties versus physical properties. Whoa! Okay, you got your supplies?
Yes.
All right. So, just to review, the physical properties of matter are the things that you can see, touch, and feel. That's stuff like color. Like the feel of it, is it soft or hard? How much it weighs, what shape it is. Those are the physical properties of matter. Now the chemical properties of matter come into play when you mix things together. So chemical properties are things like if you put it near fire, does it catch on fire? If you leave it out in the rain, does it get rust on it? If you taste it, does it taste like acid, like sour? Or does it taste bitter? Those are things that regard chemical properties. So we can usually observe chemical properties when we mix things together. So matter is basically split into two categories. We have acids and we have bases. Acids are things you can sometimes eat, although some can be very strong and can burn holes in material. Examples of acids are things like lemon juice, vinegar, stuff that has that kind of sour, citrusy taste to it. Now on the other end of the scale, this is called the pH scale by the way, we have our bases. Bases are things you do not want to eat. And you do not want to mix bases with other acids randomly because they do things and they can produce poisons when you do that. So bases taste bitter. If you've ever had your mouth washed out with soap by your mom for saying a bad word, you are trying a base because soap is a base. Bases also tend to be slippery, and some bases can conduct electricity when you put them into water. So to repeat, acids are things that are like that taste sour that you can sometimes add to food. Bases you definitely don't want to mix together. You don't want to taste. You don't want to try. You don't want to combine them with other bases because they can do all kinds of random things. All right, so how do you tell if a liquid is an acid or a base? To do that, you use something called a pH indicator. So for today's experiment, we have a pH indicator right here. This is a homemade one. You can buy them in the store for like testing pools and stuff like that. So this pH indicator was made by soaking black beans in water overnight. When you add this black bean liquid to an acid, it turns like a pinkish reddish color. When you add it to a base, you'll see a completely different color change reaction. So when you see that color change, that's an indicator of you seeing a chemical reaction. Because remember, one of the signs of a chemical reaction is there a color change? All right, so we're going to go ahead and begin doing this experiment. You ready? Yeah, all right, stand up. Okay, so some rules for an experiment like this. Number one, do not smell or taste any of the materials we're testing. Some of these are really not meant to be inhaled, so I'm going to do those ones. The ones that are safe for human consumption, Ellen's going to be doing, okay? So what we're going to do is we're going to put a couple of drops of the indicator into each container, and we'll show the camera what happens. You ready for the first one? All right, so first we're going to start off with this kind of orangish one right here. Okay, hold your container. All right, and drip. Okay, so what color did it change? So you can see it kind of turned a reddish color to it. It's definitely a different color than it was when it first started. So we'll put that one over here as probably going to be an acid. Okay, ready for the next one? Okay, we're going to do this one next. Kind of a clearish, milky liquid. Okay, ready? Drip. So that one had a really strong reaction. And the lighter the pink color, that means the more acidic it actually is. So we'll put that one in the acid category for sure. Okay, ready for the next one? Okay, ready? Drip. And we can see here we have a little bit of reaction at the top especially. Let's give it a little bit of a shake. And you can see we have that kind of pinkish color on that one too. Remember, we don't pick up or open. I open them for you, okay? You ready? Let's do this one next. Here's our next liquid. Drip. We'll do a little bit more. Okay, let's do a little bit more. All right, ready? Drip. Okay, let's shake that one up. So what color is that one? Did it turn pink or is it kind of a rusty red? Yeah. So we don't see a big pink color on this one. It did change color to like a lighter pink color, but it's not a rusty red one. Is it yummy? I don't know if I want to drink that one. Okay, here's our next liquid. And it's clear. You ready? Here. Whoops, I think we missed. Let's try that one again. Okay, and whoops, we missed again. Let's wait till it gets in the container, okay? Ready? Okay, now squirt. Alright, so this one, we don't see much of a color change at all. It just looks like you added bean juice to the liquid and didn't really make any difference. Doesn't look like a chemical reaction, looks like more of a physical reaction. Okay, next one. So here we have another kind of cloudy material. You ready? And let's do one more scoop, okay? And wait. Wait. There we go. And we can see on this one, what color is that one? Very bright pink. It's a very bright pink color. So all of these ones kind of fall in the same category. This was last. Remember, Daddy does those ones. Daddy will do those ones. So we have a pink color there, a very pink color there, another pink color there. The last one, okay? Then we have a little bit of a red shine there, but not much. We have a pretty pink color there. And this one just looks like you dropped bean juice in water, which is what we did. This is water. Okay, now for the last two, Mr. Thill is going to take over because these are going to have a different reaction. So you can watch, but you can't touch, okay? Alright, so here's the first one. Remember, you can't touch it. Okay, so did you see that? When we dropped that in, we had a completely different color change reaction. What did that change color to? Is that pink or orange?
Orange.
Yeah, it's like an orange or yellow color. So that's not an acid. That's actually a base. Now this is going to be a little trickier because it's already got a yellow color to it. But let's add some pH indicators to see what happens. You ready? Oh. So you can see here that we have a darker color attached to this one. So you can kind of see the spectrum here, how we go from a lighter orange or yellow color to a darker yellow or orange color. So that's an indication that these two liquids are not acids, but they're bases. Can you say bases?
Bases.
Alright, so now I'm going to show you what each item is. So we'll start with the bases first. So this one's ammonia, used to clean stuff. Don't drink ammonia, don't mix it with things. It can produce poisons when you mix it. This one is bleach, another cleaning material. So this is obviously something you don't consume, smell, or drink. That's why it's got the lid on it. Right here we have water. Water's neutral. It's not really an acid or a base, so that's why it looks like we just put bean juice in the water. This one, you can probably tell, is orange juice. The yellow color probably didn't help much on the orange juice. Now this one, this was, I can't tell anymore, the thing came out. I think it was, oh, ginger ale. And ginger ale, as you can tell, turned a really, really pink color, which makes sense because if you look at the ingredients of ginger ale, one of the ingredients there, if you can tell, is citric acid. This one right here was lime juice. This one right here was apple cider vinegar. And this one here was our lemon juice. So if we were to sort them by acidity, it would probably go something like this. You drank a lot of that, didn't you? And there's our rainbow of colors that show acids and bases. So each of these color changes is an indicator that when we put the pH in there, we had a chemical reaction, with the exception of maybe the water, which just looked like we mixed two things together.